Well, thinking about the major changes over the last 40 years in my career, I arrived home in Vancouver in 1973, just after the first successful amniocentesis results were coming out. And so we started with a very long involvement with women who were at risk by virtue of age. As much as we tried to divest ourselves of this and give it to the obstetricians to do, the counseling fell upon us for advanced maternal age. But eventually that morphed into other things. This is before we had what is now standard practice in the biochemistry lab, the ability to study various inherited diseases, lysosomal storage diseases, Tay-Sachs disease, those kinds of things. Now it's a routine matter. So I witnessed the birth of genetic testing for Tay-Sachs disease in Montreal. We brought it back to British Columbia and screened the Jewish community with their assistance. Then it snowballed into more and more sophisticated cytogenetic techniques, more and more sophisticated biochemical genetic techniques. And then about 1985, 86, this business of DNA for Fragile X came about. In Kingston, for some reason, I don't know the history there, but there was no end of families with Fragile X. And I remember seeing this video yesterday of Stephanie Sherman, who's now in Honolulu, and Sherman's paradox about Fragile X. And she came to Kingston to review the files of my colleague there, Michael Partington, who had about 38 families. So we're having lunch one day, and I chatted her up, and I said, have you ever seen a patient with Fragile X? There's a PhD, basic science research, working at the cutting edge of Fragile X, had never been in the same room as someone with Fragile X in them. Well, as serendipity had it, I was seeing a family that afternoon, so Stephanie came with me. And that was sort of a little thing for me with other PhDs who were so welded to the lab who never got out and saw the patients. And I have witnessed the most profound change in their behavior. So I'll give one example. In Montreal, we did a project on this other syndrome. There was a young PhD candidate who was going to work on this Rett syndrome thing. And she came and spent the day with me at Children's Hospital in Montreal. I had a clinic there and when I was traveling. And 2 months later, I visited her lab, and pictures all over the wall of these kids. You know, she really hadn't understood what this was about. And did she get motivated then, you know? So I insist that anybody who's doing a PhD on a human disease, you got to spend some time with the family, at least one time. So Stephanie started that. Then molecular genetics just became more and more. We were doing linkage analysis for Huntington's disease, and this was in the mid-'80s. Michael Hayden had started this big institute in Vancouver, and he had 17 sites across the country that were sending samples and linkage analysis, and that then became much more precise with actual gene testing. That then set up a really interesting dynamic. He had done such good work with his team in the whole concept of pre-symptomatic testing and guidelines and things you should follow, that he and I were approached by the BC Cancer Agency then to do the same kind of protocol for testing for BRCA1 and eventually BRCA2. So they really essentially took the Huntington's protocol and made it into BRCA1 in a way we want. So we had a real growth in pre-symptomatic testing for these cancer diseases.